I'd like to start things out by thanking you for taking the time to attend today's presentation. Hello, my name is Lance Zurich, and what we're going to do today is we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle high schools and homeschools to the fundamental principles behind mechatronics. Now, each of the sets we're going to be looking at today are designed for conducting what's essentially a project-based class, and that's where students are going to be required to design and build a series of original prototypes, all based upon their own research and activity. And each of these sets include standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many technology-focused presentations for education start these days, and that's with discussing the skills gap that exists. Now, when you hear someone reference the skills gap or speak about the need for better STEM education in schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics. So when you hear someone talking about this, what they're essentially talking about is the urgent need to prepare our students with the background that they're going to need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our parents or our grandparents, essentially a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly, so to speak. But now, students must be prepared to enter a world that is increasingly focused on areas such as programming, automation, IoT, and all sorts of rapid advances in technology. So essentially, students must be able to demonstrate technical literacy and aptitude if they really hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Because really, when you think about it, every new advantage that we enjoy, this could be things like the tablets and the smartphones that, we all use daily, all of these things were created because of individuals who had to help make those advances. Now, if you look at countries all around the globe, countries like China and India and so many others, they're making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. So, really, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements that we rely on to stay competitive on the world stage and, of course, to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already pretty much in agreement about the importance of STEM and technology-focused programs, we're going to move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All, of course, extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. But just how highly prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these sorts of prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they really need to start developing these habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, and it's whether you're in the classroom or the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that's going to get them interested and involved in the learning process and not just memorizing obscure facts or ideas just for the purpose of taking a test. No, what you really need to do is to help students to be successful and to really encourage them to consider pursuing further education in subject areas like this. Educators need to be able to present the material in a way that makes it relevant, which means, of course, answering the eternal student question, which is, why do we need to know this? And it also needs to be engaging in a way that holds the student's attention better than textbooks and lecture presentations will. It has to be something that has visible real-world applications and where the students can get involved in doing things hands-on. So it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which is designed as an introduction to the world of mechatronics, and the other of which is intended to be essentially a standalone class dedicated to the subject. In both cases, these were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that's relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. And the curriculum is also designed for offering a project-based learning program. And what project-based means is it means that solving the problems that arise in each of the units is going to require the students to be actively involved in the research, the design, the trial and error, the experimentation, the activities, everything that basically goes up to the building of the actual working prototypes that are going to be required to provide the answers to the problems. And students aren't going to be asked to do this on their own. They're instead going to be asked to work in small groups or teams of 4 students each. And this is done basically to help develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And then when we talk about soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And essentially, well, I was going to also mention that we used to have a software that you would have to pay for that was very affordable, but instead of being affordable, as the slide says, it's actually free now. So you get access to that with the building set as well now. Now, the curriculum is designed to enable teachers of all backgrounds, and it's even teachers from non-science or technology-focused disciplines, to have the information they're going to need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorial sections on familiarizing students with the building system that's going to be used to address the projects being presented in each unit. The units in the curriculum are designed as a series of projects. Each of these projects is presented to the students in the form of an engaging real-world style scenario. And in each of these scenarios, students must work together in small teams. Again, these are teams of 4 students per group to create a solution to solve the problem. The project units each contain embedded academics. Now, at the end of each unit, students are going to be required to make a formal presentation of the prototype that they've created to address that particular unit's real-world scenario, and they're going to have to explain the reasoning behind why they constructed the prototype the way they did. Now, there's a technical literacy task driven by each of these projects. As students work to address each project, they're going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activities. Now, again, as required by each project, students are going to be asked to create original prototypes, and of course, they're also going to have to create any required programming-based solutions that might be needed, and also to maintain detailed documentation during the entire process. Now, as I've mentioned his name a few times during the presentation, again, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White, who you see on the screen now. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs both for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing subjects like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. And these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. And as I mentioned before, the projects or the programs are designed to be project based. Now, when students ask a question like, why do we need to know this? The reason behind that is usually because the subject matter that they're being presented with might come across as probably too abstract to ever be useful in their lives. And with this project-based approach, instead, students get to see firsthand why these things would be necessary or why they would be useful to know. Now, the concept of working in these small groups to help solve the project problems that they're presented with helps students, again, to develop the high demand soft skills that employers look for. Again, these are skills like communication, analytical skills, quantitative skills, flexibility, adaptability, problem solving, and so on. Now, in this project-based format, all of the subject matter is integrated. And what that means is the math is mixed in with the reading and the writing and so on. And this kind of approach is really ideal for STEM education. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research, the testing, and the group give and take, just to provide a couple of examples, this format allows for a much deeper exploration of problems than traditional teaching methods may allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project at one time, you should see variations in the types of prototypes and solutions that they're coming up with. Now, this could, of course, be because of differences in creativity or differences in the research or the approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers and that often there's not only one right answer, but that there can be many, and then it's a matter of determining which one might be better. Now, each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge that they need to draw on to complete each project just in time. And students are going to be required to do extensive research as they complete these projects. Research, again, that is utilized in the design, the prototyping, the testing, evaluation, and redesign phases of each of the solutions. And again, the Studica Mechatronics program sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. And the team approach, as stated before, again, helps promote these soft skills, the communication, the ability to work well with others, and leadership. And each of these sets offers an easily scalable approach. All you have to do is you get to divide the number of students in your classroom by 4 to determine the number of sets that you're going to need for any given class. And everything you need to conduct the program, including, of course, now it's not affordable. It's free software that we give you. Everything else you need is included right in the box. So that means you get the access to the free curriculum download. That comes with whether you purchase 1 set, 10 sets, what have you. You immediately get access to that curriculum download. You, of course, get access to the software that's going to be needed. You also have all of the building materials needed for the creation of all of these prototypes. And the building materials being used are from the unique Fisher Technic building system. And among the components that are included in each set are 2 robotics controllers and 2 power supplies. Now, just to backtrack a little bit for those of you who may not be familiar with Fisher Technic, let me provide you with just a little bit of background on that. Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets where they're designed to simply stack, the Fisher Technic system was created with more of an engineering mindset. And by that, I mean that the core building block that you see on the screen now in the Fisher Technic system is unique in that it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the system also includes a very wide selection of very specific parts. These are variations on things like gears, girders, sensors, and much more, which are all designed to enable technical builders to address equally specific design tasks. Just to give you a little more background, the system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, at the time of his death in 2016, Mr. Fisher held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, some of the things that Mr. Fisher is known for include things like he was the inventor of synchronized flash photography, and this was back in 1949. And he's also credited as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Now, his company, the Fisher Group, continues to employ thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing. And on top of that, they also provide consulting services related to high-end automated processes. Now, with all of that said, let's begin looking specifically at each of the two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program sets, or for those of you who prefer acronyms, you could refer to this one as SIMP. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to the free downloadable 242-page curriculum document, in this case entitled Mechatronics Fundamentals, again written by Tom White. The curriculum itself contains enough activity materials to fill approximately 45 academic hours. Now, with this in mind, we recommend this set for insertion into regular related class activities to be used as a short class unto itself. You could use it for after school program use, or of course, it could be used for homeschool use. Now, again, the curriculum created for the set is standards focused, again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. Now, the set is designed for use in middle or high school classes, or again, for addressing these grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this is going to, again, include everything from gears, wheels, axles, sensors, blocks, and so on, as well as the two robotics controllers and the power supplies, along with the software access. The curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that come up during the course of the curriculum, and they include sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, working with digital branching or analog sensors such as the photocell LDR, uh, again, working with analog sensors such as the NTC resistor or the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered by the second set, and that is the Studica Teaching Application of Mechatronics Program, also known as, if you want to use an acronym for this one, you could call this one STAMP. Now, this set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamentals behind mechatronics. Now, this set includes access to a free downloadable 400-plus page curriculum document, in this case entitled Mechatronics Applications, again by Tom White. Now, the activity materials in this curriculum document, when used in conjunction with the contents of the set, are designed to fill approximately 180 academic hours. So what we're talking about now is essentially 4 times the amount of academic material as was covered by the previous set. Now, again, this could be seen as a more expansive version of the material touched upon in the previous set. And because of this, it's designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day for 5 days a week or the equivalent. So again, if you want to do a daily class period of 50 minutes a day, if you're going to do it all in one day and do essentially a 5 times 50, in a 4.5 hour period, you could do that. But it's essentially set up for you to do this every week for a full school year. Again, the set is designed for offering students a standards-focused project-based learning experience, and it's designed for use again in middle school, high school, or for addressing similar grade levels in a homeschool environment. The materials here will consist of a selection of over 1,200 Fisher Technic building components. And again, this is going to include a wide array of gears, blocks, sensors, axles, all of the things that are included in the system, as well as the 2 robotics controllers and 2 power supplies. And again, you also get access to the software needed for the controllers. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as there were with the previously discussed set. And this is going to include units on sketching and documentation, simple machines, mechanical systems, basic electricity, and this is followed by project-specific units focusing on the creation of a garage door, of an elevator control, of an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, there are links that are provided to tutorial sections and activity materials for students to utilize. And these are going to include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and working with the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming, working with digital branching, learning about logic gates and combinational logic, edge triggered versus level triggered, learning about pneumatics, working with variables and positions, learning how to record positions, how to create a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and working with data. Now that we've had a quick look at how each of these sets differs and the specific subject matter being addressed by each, let's now look to exactly how the curriculum document itself is structured. Now, both versions of the curriculum will share the same format when it comes to the structure of each of the project units, and as already discussed, each version is going to include tutorial materials, activity materials, standards, and supplementary material. Now, in each case, the curriculum is also designed to be turnkey. And what do I mean by that? Well, essentially, each unit is designed to clearly spell out everything that's going to be addressed. So, excuse me a second. Ah. So each unit is designed to clearly spell out everything that's going to be addressed, and again, provide tutorials and other information as each of these topics arise. Now, this is done specifically to enable teachers from all sorts of backgrounds, and that includes those teachers who come from a non-science or non-tech focused background to enable them to quickly become comfortable with delivering the material simply by reviewing the curriculum of each section before they present it in class. So everything's going to be spelled out. Again, you have all these links to anything that comes up that whether it be the teacher or the student, if you're not sure about it, how to address it, it's going to all be put down for you. Now, each unit presented in the curriculum for each of these sets will include the following sections. It's going to include an introduction, talking about the purpose of the project and the concepts. An outline will be provided. The standards will be addressed. Assessment rubrics will be provided. There's the essential question, the student scenario, a daily plan, and then there are also vocabulary and other resources. Now let's take a look at each of these in a little bit more detail. As I said, each unit will start with an introductory section and the purpose of the project. And now, as you would likely gather from that, this is the section that provides a brief description of the topic that's going to be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they are learning this material and why it's important for them to know. The next section focuses on the main concepts to be addressed in the unit, and these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize not only today for the purpose of the project, but also to draw upon as they move forward in STEM-related fields of study and if they choose to pursue it further in STEM-related careers. Following this, we encounter the outline. Now, in this section, we get to drill down more specifically to what's going to be addressed in the unit. Now, as the example that I'm sharing on the screen right now is taken from the unit that addresses aspects of programming, you'll see that we touch upon areas such as the methods for writing programs, which includes things like flow charts, word problems, and so on. Different program characteristics, for example, open or closed loop, working with branching, digital, analog, subprograms, and so on. The next section of each project unit will focus on the specific academic standards which are going to be addressed by the unit. As you can see, this includes the college and career readiness math standards, the reading standards for literacy in history and social studies, the writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literary tasks. Next, we come upon the essential question, and this can be thought of as the big picture question of what's going to be focused on in each of the smaller individual activities, and of course, all of the aspects of the larger project, which students are about to be asked to complete in this section. Moving right along, we get to the student scenario, and this is where the specifics of the project to be addressed are finally spelled out. Now, the student scenario is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved by the creation of some sort of a device, a machine, or a mechanism. Now, as I mentioned before, students are basically going to not going to do this alone, but they're going to be asked to work in small teams to craft an answer to the challenge being presented. Now, solving this problem is going to require each of these teams of students to design a unique and original answer to the question, which once again is usually in the form of creating some sort of a working prototype along with whatever programming may be required to power it, or to control it, I should say. Now, just to provide an example, if you look closely at the student scenario shown on the screen right now, you will see that the project in this unit has the group of students taking on uh, they're basically the role of members of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are going to be required to design a very specific type of control system for a new line of garage doors that they're designing. And the manufacturer's requirements here are all spelled out, such as, in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything's going to be in the way of a closing door, and also the incorporation of an automatic light. So, each team of students is going to be tasked with creating both a unique and original prototype. In this case, it's of course a garage door opening system, as well as the programming needed to control the prototype. Now, as they move through the challenge being put forth in this scenario, each team of students is going to be required to document the entire process in both a design notebook and a digital engineering journal. And this means notating all of the research that they go through, any trial and error experimentation that they get involved with. They have to keep copies of any design sketches or revisions that they make, and so on and so forth. Now, at the end of each of these project units, again, as I mentioned, each team of students is going to be required to conduct a formal presentation in front of the class during which they're going to present and demonstrate their prototype and their programming in action, much as they would be required to do if they were doing it for an actual employer or a client in the real world. Now, the next section we encounter in the curriculum is the daily plan, and this is the section that clearly spells out, both for students and teachers, what's exactly going to be expected of the students, how the teacher is going to conduct that day's classroom activities, and what specific subject matter is going to be covered. So you'll see that some days may involve more discussion topics. Other days may be more focused on research or perhaps even the building of small projects that are going to help provide the building blocks that students are going to draw on to build the larger projects that they're working on. But in short, you can think of the daily plan as kind of a roadmap, and it's designed to keep everyone on the same pathway. You'll also see, too, that as along the way, as different aspects are addressed in each day's activity, such as, for example, what is required in a design notebook, or how to use the control software, how to work with the robotic controllers or flow charts or what have you. But as each of these things comes up, there are links to sections that are going to provide further instructions on information on just what is needed or how to do certain things. Now, at the completion of each unit, on the last day of the daily plan, there's also a section that contains vocabulary, and this is essentially words and terminology introduced during the project unit. And there's also a selection of useful resource materials. And the resources can contain a mix of different types of things. You could have carefully vetted websites and video links. You could have PDF documents. You could have PowerPoints, what have you. It's really going to just depend on the unit. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this is going to include information on how the various parts fit together using the pin and groove assembly method, how to identify the different types of parts from the various types of gears and girders and blocks and axles and so on. And students are also going to get to build a very basic sample model just to help familiarize them with how the system is used before they move on to the projects being presented in each unit. And as learning about and maintaining proper documentation is one of the areas that is stressed throughout the course of this curriculum, there is a section which clearly details just what defines each type of documentation that you see listed on the screen now and what is going to be required for each. And because the process of conducting this type of more open project-based class activity might be a new thing to many teachers, there's also a section that discusses specifically project-based STEM education and its benefits. And that essentially completes our overview of these two sets. So we're going to review again very quickly the contents and purpose of each of these sets, but this time we're going to provide the pricing. First, of course, we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused, project-based introduction to the core concepts behind mechatronics. Again, it includes access to the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. And the curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity and material to fill approximately 45 academic hours. Because of this, it is again designed for those educators who wish to offer a shorter class on this material, who can use it in class, after-school programs, or for those who are going to use it for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as, of course, by homeschooling parents seeking to address STEM and mechatronics for these grade levels. The physical materials in the set will include a selection of over 700 components, including blocks, gears, sensors, and much more, all taken from the Fisher Technic building system, along with 2 robotic control units and power supplies. And these materials will once again be used to construct the various mechanical prototypes addressed in each project unit of the curriculum. The software access is again provided with each set, so it's not separate. And again, each set is designed for use by a team of 4 students at a time, with pricing starting at just $699 for a single set. And there is discount classroom pricing for groups of 20 students and above, which is available by quote upon request. Now, if we're looking at the other set, the Studica Teaching Applications of Mechatronics Program set, again, this is designed as a more in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, all based around a highly detailed 400-plus page curriculum document entitled Mechatronics Applications, written by noted STEM expert, again, Tom White. Now, when used in conjunction with the building components included in this set, again, this curriculum is designed to provide enough activity materials to fill approximately 180 academic hours. So this means that it's designed specifically for those teachers and homeschoolers who are able to dedicate more time to it, essentially a daily class period of 50 minutes per day, 5 days a week, or the equivalent for a full academic year. The set is designed again for use in middle schools, high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. Each box that you get contains an assortment of over 1,200 components from the Fisher Technic building system. Again, the blocks, girders, gears, axles, and much more, along with the two robotic control units and two power supplies. The access to the software is provided, so you don't have to go elsewhere for that. And again, each set is designed for use by teams of 4 students, with the pricing for a single set starting at just $799 each. And again, discount classroom pricing for 20 students or more is available by quote upon request. And just because I've touched on the software several times, just to give you a little bit of background, what is used here is Fisher Technic RoboPro graphic programming software. It basically uses a flowchart style design where students move the icons around and create flowchart style programs. It's for use with Windows 7, 8, and 10. It's not used with Chromebooks, unfortunately, not used with Macs. So just please keep this in mind if that's going to be a sticking point for you. Please note that Windows 7, 8, 10 should be fine with 11, I believe, but not Chromebooks, not Mac. And we, of course, again, will include the access to that with each set. So if you do have any questions at this point, I would ask you to either use the question and answer window or the webinar chat window, both of which are found on the Zoom toolbar. If I don't see any questions come up, I will go 1, 2, 3. And instead, I'm going to provide some notes on how you can take like to speak with your dedicated educational representative, or if you would like to speak with me about this, you can call us. Studica is our toll-free number is 888-561-7521. Our email address here for general inquiry, general quotes is info@studica.com. And if you'd like to email me directly, you can do so. My email is lance.zurek, that's lance.zurek @studica.com. On that note, I'd like to thank you very much for taking the time to attend today's presentation. We look forward to hearing from you. Have a great day.